this is section 2.7 and 2.8 combined. It really should be just one big section. So that being the case, I'll be doing stuff from 2.7 and 2.8, jumping back and forth. So this video is going to be a little bit longer because it's a combination of 2.7 and 2.8, where we'll be doing the derivative. Okay, so we'll pick up the concept of the derivative now. On page number 140, okay, derivatives and rates of change. Okay, rates of change is a form of the derivative. So first, let me give you derivation of the derivative. All right, here's a point x, and I move h to the right, x plus h. So this is x comma f of x. This is x plus h comma f of x plus h. Okay, so if I connect these 2 points to get a secant line is a line which touches 2 points of a graph. By the way, this has nothing to do with the trigonometric secant. Okay, so the slope is y2 minus y1 divided by x2 minus x1. So the slope of the secant is f of x plus h minus f of x divided by x plus h minus x. Can't do anything with this, but this is just h. Okay, so f of x plus h minus f of x all over h. Now, if I take the limit as h approaches 0, so keep this point fixed, have this point come closer and closer and closer, i.e. h approaches 0, then the secant line approaches the tangent line. So the slope of the tangent line is the limit as h approaches 0 of this expression f of x plus h minus f of x all over h. And we're going to use this as a definition of the derivative. So definition of derivative, the derivative of f of x is f prime of x. This apostrophe means f prime of x is what we say. It's this limit, provided that it exists. We already know we've seen limits that don't exist. Limit h approaches 0 of f of x plus h minus f of x all over h. Okay, you can put this on your formula sheet. Okay, now the book on 2.7 and 2.8 gives you lots of other definitions of the derivative. I think it's unnecessary. You only need the one, and they show you that one in 2.8, page number 152. And there it is, f prime of x, f apostrophe x, limit h approaches 0, f of x plus h minus f of x all over h. So we'll be using that to compute derivatives. Okay, so as I do some of these problems, let me hasten to add that some of you may have had some exposure to calculus in the past and you know some derivative shortcuts. You may not use any of those shortcuts in this chapter. You must use the limit definition. If you do not use the limit definition, you will get no credit or very little credit for your answer if you use one of the derivative shortcuts. Okay. All right, so let's show you the homework, 2.7. Okay, so we have 5 to 17 odd, 21 to 35 odd, and 43 on page 148. So here we go. Starting with problem 5. And that's 11, 13. Okay. So again, I'm willing to go fast and I talk fast also because this is a video. You can pause, rewind, fast forward as much as you wish. So in order to make the video shorter, I'm talking faster. So that's why I'm going faster than I normally would in a regular face-to-face setting, let's say. And of course, that way the video is shorter. Okay, and we had to go up to what, 40? Go 2.7, 43, not 47, 43. 39, 41, 43. Okay. And then 2.8, again, it's on the derivative. Again, I'm treating this all as one section. Definition of derivative, it's on page 1, get this thing focused here, 152. And 2.8, 1 to 13, 21 to 31, 41 to 44. So we have to go as high as 44. So page 160. There's 1, 3, a bit bigger. 5 and 7, 9, 11, 13, And then let's see on this page, 21 and on. And I think you didn't have to do any of these. So just 41 to 44, and I think that's about it. Okay. Here we go. 2.7, number 7, y equals radical x at 1, 1. Find the equation of the tangent line. So to find the equation of the tangent line, you take the derivative. So by definition, f prime of x is limit h approaches 0, f of x plus h minus f of x all over h. So in this case, limit h approaches 0, radical x plus h minus radical x all over h. Okay. To work this one out, you multiply top and bottom by the conjugate of the numerator, radical x plus h plus radical x. That way, this looks like a minus b, a plus b, which is a squared minus b squared. So if this thing squared is just x plus h, this thing squared is just minus x, all over h times radical x plus h plus radical x. X's cancel out. H cancels with this h, leaving you a 1. So limit h approaches 0, 1 over radical x plus h plus radical x. Now you can plug in 0 for h, 1 over radical x plus radical x, 1 over 2 radical x. So this is the derivative function, which gives you the slope of the tangent line. Now I plug in whatever they ask me to. They tell me to plug in 1. X is 1. So 1 over 2 radical 1, 1/2. So the point slope form, y minus y1 equals m times x minus x1. Y minus 1 equals 1/2 times x minus 1. And you can stop there. Okay, jumping to 33, it's a little bit harder. F of t is 2t plus 1 over t plus 3. So the derivative is limit h approaches 0 of f of t plus h, 2 parentheses t plus h plus 1 divided by t plus h plus 3 minus the original function 2t plus 1 over t plus 3 all over h. Okay, now to clean it up, and it looks very messy. Okay, whenever I see something like this, where there's a fraction on top of a fraction, I will write it as, instead of dividing by h, I will multiply it by 1 over h. Right? Dividing by h over 1 is the same as multiplying by 1 over h. Okay, this is 2t plus 2h plus 1, t plus h plus 3. Leave that alone. So I need a common denominator. So multiply this side by t plus 3, top and bottom. Multiply this side by t plus h plus 3, top and bottom. Okay, so I have a common denominator. Distribute all this mess out. 2t times that and that, 2h times that and that, 1 times that and that. And then 2t times that, and that, 1 times that, and that. Distribute the minus. This is all what it comes out to be. Limit h approaches 0 of 1 over h. 2t squareds cancel out. 6t cancels out. 2ht cancels out. T cancels out. 3 cancels out. All I have left is a 6h minus h, which is 5h. This h cancels that h. So I have limit h approaches 0 of 5 over t plus 3, t plus h plus 3. Now I plug in 0 for h, and I get 5 over t plus 3 squared. Okay, the last thing is it says, what's f prime of a? I just plug in a, 5 over a plus 3 quantity squared. Okay. Then going back to 2.7, number 9, y is 3 plus 4x squared minus 2x cubed. So it's quite a bit of work to find a derivative of this one. So limit h approaches 0, f of x plus h. So put x plus h right there, square it, x plus h right there, cube it, minus the original f of x all over h. Okay, x plus h squared is x squared plus 2xh plus h squared. X plus h cubed, x plus h times x plus h times x plus h. I'll let you work it out. It's x cubed plus 3x squared h plus 3xh squared plus h cubed. And distribute here, distribute here, distribute here. And now distribute everything. 3 plus 4x squared plus 8xh plus 4h squared minus 2x cubed minus 6x squared h minus 6xh squared minus 2h cubed. Copy, copy, copy. 3's cancel out. 4x squared cancels out. 2x cubed cancels out. So I have that one, that one, that one, that one, and that one. They all have an h. So I factor out the h, and that h is going to cancel the h's on the bottom. So 8x plus 4h minus 6x squared minus 6xh minus 2h squared. Cancel, cancel. I have this. Now everywhere that I see 0, everywhere I see h, plug in 0. So that's 0, that's 0, that's 0, The only thing left is 8x minus 6x squared. Okay. And they ask for y prime of a, so I just plug in a, 8a minus 6a squared. And they want the equation of the tangent at 1, 5. So I plug in x is 1. You say, what about the 5? Well, that's y, but my expression doesn't have any y, so don't worry about it. So I plug in 1. 8 times 1 minus 6 times 1 squared. M is 2. Point, slope. So y minus y1 equals m times x minus x1, and you can stop. So in general, once you get the point slope form, you can stop. You don't have to keep going. You know, we're busy doing the calculus, so we're assuming we can do the algebra. We don't feel like it. We're focusing on the calculus. Okay. All right, 13. Y equals 40t minus 16t squared. The velocity at t equals 2. Velocity also means derivative. Okay, so the derivative of the distance function is the velocity function. So limit h approaches 0. 40 times t plus h minus 16 times t plus h squared minus the original function, 40t minus 16t squared, all over h. So this is f of t plus h minus f of t all over h. And again, some heavy duty algebra. This comes out to be t squared plus 2th plus h squared. Distribute, distribute, distribute. Ends up looking like this. Limit h approaches 0 of 40t plus 40h minus 16t squared minus 32th minus 16h squared minus 40t plus 16t squared. Okay, these two cancel out. These two cancel out. So I have that one, and that one. They all have a factor of h. Factor out to h parentheses, 40 minus 32t minus 16h all over h. H cancels out. That's usually the name of the game for these kind of problems. For these kind of problems, you generally want to cancel out the h. Because now that you have this, you can just plug in for h. So limit h approaches 0 of that, just plug in 0 for h, 40 minus 32t. And now you can plug in anything you want. They tell me to plug in 2. So y prime of 2 is 40 minus 32 times 2, negative 24 feet per second. And negative means we're going down in this particular case. Okay. Okay, 2.7, number 25. Let me show you that one. I'm kind of jumping around here. 2.725. Sketch the graph of a function that is continuous on a domain negative 5, 5 open. G of 0 is 1. G of 0 is 1. G prime of 0 is 1. Slope is 1, rising at a 45-degree angle right there. G prime of negative 2 is 0. Slope at negative 2 is 0. And limit as x approaches negative 5 from the right is infinity. So if I get close to negative 5 coming on the right side, I approach infinity. And limit as x approaches 5 from the left is 3. So come toward the left and comes like that. So this is the graph for 2.7, number 25. 2.7, number 11. The particle starts by moving to the right along a horizontal line. The graph of its position function is shown in the figure. It goes like that, like that, like that, like that, like that. Okay. So the velocity will be the slope. Okay. This is meters. This is second. If I take delta y over delta x, change in y divided by change in x, I have meters divided by seconds, meters per second, that's velocity. Okay. All right, so positive slope, we're moving to the right. So when is the particle moving to the right? From 2 to 3. Also from 4 to 6. Oh, sorry, from 0 to 1. So parentheses 0, 1, union 4, 6. When is the particle moving to the left? Falling, so between 2 and 3. Standing still, well, that means we're not moving anywhere, same distance, so the slope is 0. So standing still is 0, 1, union 3, 4. You draw a graph of the velocity function. Okay, between 0 and 1, the slope is 3. Between 1 and 2, the slope is 0, velocity in meters per second. Between 2 and 3, the slope is -2. Velocity is -2. Between 3 and 4, we're at rest, slope is 0. And between 4 and 6, the slope is 1. Okay, so that's what it looks like. Between 0 and 1, 3. Between 1 and 2, 0. Between 2 and 3, -2. Between 3 and 4, 0. And between 4 and 6, 1. So this is time versus velocity. Okay, 17. For the function g whose graph is given, arrange the following numbers in increasing order and explain your reasoning. Okay, 0. And these are slopes. Slope at -2, slope at 0, slope at 2, slope at 4. Imagine you're on a ride, a roller coaster ride, like so. So here you're increasing, decreasing, increasing, increasing. The only one that has a negative slope is right here. So g prime of 0 is the smallest value, because that's negative. All the others are positive, so the next number would be 0. So the second on this is 0. I have 3 positives, that one, and that one. So I just go in order of steepness. That looks like the steepest. This is the least steep, and this is in the middle. So the next larger value is g prime of 4, followed by g prime of 2, which is steeper. And then this one is the steepest, you're looking up the most. So g prime of 0 is the only negative, then 0, g prime of 4, positive slope, g prime of 2, positive steeper, g prime of -2, steepest. Okay, and let's see. Problem 21. If an equation of the tangent to the curve at the point where a equals 2 is y equals 4x minus 5, find f of 2 and f prime of 2. Okay, f prime of 2 means slope of the tangent line, where the slope is 4. So f prime of 2 is 4. What is the function value? Well, the function value will match the tangent to the curve. So I just plug in 2. 4 times 2 minus 5. F of 2 is 4 times 2 minus 5 is 3. So you plug in 2, find f of 2. F prime of 2 is the slope. Slope is 4. So that's it for that. Heads up, I'm going to get this a little bit later, but for 2.8 problem 31, it asks for x plus h to the 4th power. It's x plus h squared times x plus h squared, which is x squared plus 2xh plus h squared, times another x squared plus 2xh plus h squared. You can multiply that out. Another way to get it, some of you might recall, is something called Pascal's triangle. Okay, if you've never heard of Pascal's triangle, it goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So in the triangle, the outsides are always 1. The inside is always the sum of the two numbers above it. So in other words, 2 is 1 plus 1. 3 is 1 plus 2. 3 is 2 plus 1. 4 is 1 plus 3. 6 is 3 plus 3. 4 is 3 plus 1, and so on. And these actually give you the coefficients, binomial coefficients of a plus b to the 0, 1, 2, 3, and 4. So for a plus b to the 4th, the coefficients are 1, 4, 6, 4, 1. And then you take one letter, like a to the 4th, and they just keep decreasing, a to the 4th, 3rd, squared, a to the 1, and a to the 0. And b goes the opposite, b to the 0, 1, 2, 3, 4. So in other words, a plus b to the 4th is this mess, a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. Okay, I'm giving that to you now, but we'll need that when we get to 2.8, number 31. Okay. All right, let's see, let me go to 2.7, number 15. Okay, so s is 1 over t squared. Find the velocity, which is derivative, at a, 1, 2, and 3. Okay, so s is equal to t squared. Let me use the book. So s prime is limit h approaches 0 of 1 over t plus h squared minus 1 over t squared all over h. And again, when I get anything that looks that messy, instead of dividing by h, I multiply by 1 over h. So 1 over t plus h squared minus 1 over t squared. Common denominator, multiply this side by t squared over t squared. This one by t plus h squared, top and bottom. So limit h approaches 0, 1 over h, t squared. Okay, if I square t plus h squared, all of the terms are positive, but because there's a minus, I'm going to go minus, minus, minus. So minus t squared, minus 2th, minus h squared. all over this stuff. T squareds cancel out. These two have a common factor of h. Again, similar theme, that h cancels this h. So 1 over h times h paren negative 2t minus h. Okay. So I now have this. Now I'll plug in h as 0, put a 0 there, negative 2t on top, put a 0 there. You have t squared times t squared, t to the fourth, cancel a t. So the derivative is negative 2 over t cubed. And now you can plug in whatever you want. They tell me to plug in a, negative 2 over a cubed. Tell me to plug in 1, s prime of 1 is negative 2 over 1 cubed, which is negative 2. And then you can plug in whatever else they ask, like 2 and 3. That's perfectly fine. Okay. All right, 35 asks for the derivative of square root of 1 minus 2x. Okay, page 149. Square root of 1 minus 2x. So f prime is limit h approaches 0, square root of 1 minus 2 parentheses x plus h. This is f of x plus h by the formula for the derivative, minus the original all over h. Distribute this, and we play this same game. I multiply top and bottom by the conjugate of the numerator, which is radical 1 minus 2x minus 2h plus blah, blah, blah. Okay, that should be a minus. Okay, so this is going to be a squared minus b squared. So if I square this, I just have 1 minus 2x minus 2h. And if I square this, I just have 1 minus 2x. Limit h approaches 0, 1 minus 2x minus 2h, minus parentheses 1 minus 2x, all over h times all this stuff. 1's cancel out, 2x cancels out. I have negative 2h. That h cancels that h. So limit h approaches 0 of negative 2 over radical 1 minus 2x minus 2h plus radical 1 minus 2x. Now I can plug in h as 0. So put a 0 there, that's gone. So I have radical 1 minus 2x plus another one. Well, if I have one and another, I got two of them. So negative 2 over 2 radical 1 minus 2x, which is negative 1 over radical 1 minus 2x. And then they tell me to plug in a, so just plug in a, no big deal. Negative 1 over radical 1 minus 2a. 21, find a derivative of f of x equals 3x minus 8. So this is f of x plus h minus f of x all over h by formula for the derivative. Okay. We're doing a lot of problems involving the derivative. This thing, or sometimes they give us t, and it's t plus h minus f of t all over h. Okay, so f of x plus h is 3 parentheses x plus h minus 8 minus the original function 3x minus 8 all over h. So limit h approaches 0, 3x plus 3h minus 8 minus 3x plus 8 all over h. 3x cancels out, 8 cancels out. I have 3h over h, cancel, cancel, limit h approaches 0 of 3. Well, there is no h, so the answer is just going to be 3. So the derivative is 3. Side note, derivative means slope. This is a line, isn't it? Y equals mx plus b. What's the slope of this line? 3, i.e. derivative is 3. It's constant, it has a constant slope, right? We already knew that from algebra. The nice thing about calculus is we can find slopes of curves. Okay, so the slope here is different than the slope here, than the slope here, than the slope here, right? This roller coaster, you go up and down, right? Slopes keep changing, as opposed to a straight line. The slope is the same here, 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 in any way that you wish to discuss. Okay. Okay, 2.8. So I'm jumping to 2.8, number 31. Ask for the derivative of x to the fourth. And so now I am picking up what I talked about earlier. Page 162. X to the fourth. Find the derivative using the definition of the derivative. So f prime of x is limit h approaches 0, x plus h to the fourth minus x to the fourth all over h. Okay, so just a few moments ago, I worked out x plus h to the fourth. It was all of this mess. Minus x to the fourth all over h. X to the fourth cancels x to the fourth. That one, and that one, and that one all have an h. Factor out to h. 4x cubed plus 6x squared h plus 4x h squared plus h cubed all over h. Cancel, cancel. Okay, so I have this stuff. And now I can plug in h is 0, that's h approaches 0. So put a 0 there, there, and there. 4x cubed plus nothing, plus nothing, plus nothing, 4x cubed. Okay. And I'll just add on the side, some of you know the shortcut, the derivative of this is this. If you put that directly from here to here in a test, you get almost no credit, or maybe no credit, or very little credit. Okay. If you have no idea what I mean by the shortcut, that's fine. That's actually where I want you to be right now. I don't want you to know any shortcuts yet, so to speak. Okay, 29 is kind of messy. G of t is 1 minus 2t over 3 plus t. Find the derivative. So limit h approaches 0 of 1 minus 2 parentheses t plus h. Everywhere you see t, put t plus h over 3 plus t plus h minus the original function all over h. Okay, so same thing, whenever I have something like that, divide by h, multiply by 1 over h. That's 1 minus 2t minus 2h over 3 plus t plus h. Leave that alone. And we've seen this recurring theme, common denominator, right? Multiply this side by 3 plus t, top and bottom. This side by 3 plus t plus h, top and bottom. So this is your common denominator. It's a messy multiplication. So 16 to multiply 1 times that and that, negative 2t times that and that, negative 2h times that and that. There it is. Then minus parentheses 1 times that, that, and that, minus 2t times that, that, and that. There it is, 3 plus t plus h, minus 6t minus 2t squared minus 2th. Okay, 3's cancel, t's cancel, 6t cancels, negative 2t squared cancels, negative 2th cancels. So all I have left is a negative 6h and a minus h that minus distributes. So I have negative 7h on top, limit h approaches 0, and h's cancel out. So limit h approaches 0 of negative 7 over this stuff. Now I plug in 0 for h. So the bottom is 3 plus t times another 3 plus t. So final answer, negative 7 over 3 plus t, quantity squared. Okay, we're trying to graph some derivatives. So graph the derivative. Number 7, looks like you got a semicircle. Right, so here's x versus m or y prime. Okay, big positive, small positive, 0, small negative, large negative. Okay, so big positive, small positive, 0, small negative, large negative. Okay, so the derivative keeps decreasing. The derivative keeps going down. Okay, 11, the function's always increasing. So positive, small, positive, big, in fact, undefined, vertical tangent, and then large positive, small positive. So here we go. Small positive stays above the x-axis, goes toward an infinite slope, undefined right at the y-axis, then goes from large positive to small positive. So that's 11. Okay. Okay, now going back to 2.8, number 1. Use a given graph to estimate the value of each derivative and sketch the graph of f prime. Okay, trying to get this on the same sheet here. Okay, f prime, you want slope. The slope at negative 3, it's a small negative. I called it negative 1/3. Slope at negative 2, that definitely looks like 0. Slope at negative 1 looks like it's going up at a 45-degree angle. Call it 1. Then at the origin, it's heading up toward 2. So the slope I would say is 2. Then f prime of 1, again, it kind of looks like a 45-degree angle, so the slope is 1. At x equals 2, the slope is 0. And then at x equals 3, it's going down again. Not that steep, I call it negative 1/3. So I plotted all of these to get the graph of f prime. So it's not x versus y, it's x versus slope. So -3, -1/3, -2, 0, -1, 1, 0, 2, 1, 1, 2, 0, 3, -1/3. So here's a graph of f prime. Okay. Jumping to 27. In 2.7. 2.727. 2.723. I'll get it right. Sketch the graph where these are true. F of 0 is 0. Goes to the origin. F prime of 0 is 3. That means slope is 3. So fairly steep, over 1 up 3. F prime of 1 is 0. Slope is 0. Now you say, what's the y coordinate? I don't know. They don't tell me. It can be anywhere I want. And then f prime of 2 is -1. So slope is -1 falling at a 45-degree angle. So that's 2.723. Okay. All right, 2.7, number 29. Okay, ignore B. Here's f of x, find f prime of 2, and find equation of the tangent to the curve at the point 2, 2. So f of x is that. Okay, so we've seen a similar theme. Limit h approaches 0, f of x plus h, 5 times x plus h, over 1 plus parentheses x plus h squared. Okay, think of it as everywhere I see x, replace it with x plus h. Replace that with x plus h. Minus capital F of x, the original, all over h. Okay, so we've seen this. Divide by h means multiply by 1 over h. Split these twos up, get a common denominator. So this one needs 1 plus x squared, top and bottom. This one needs 1 plus x plus h squared. And to make things easier for myself, I went ahead and multiplied this out. 1 plus x squared plus 2xh plus h squared. And I did plus negative. It just it's minus, but to make sure I distribute, I like to make that a plus and make that a negative. Okay, so I distribute. That is 5x plus 5x cubed plus 5h plus 5x squared h, and then minus 5x cubed minus 10x squared h minus 5x h squared. All over that. 5x cancels out, 5x cubed cancels out, 5x squared h, minus 5x squared h. Okay, so after canceling, once again, I have h everywhere left on top. So h is left. I have 5 minus 5x squared minus 5xh. Sorry, these two don't cancel out, but I just combine them here. H cancels out. So I have this, and now I can plug in 0. So that's gone. That's gone. So I have 1 plus x squared times another 1 plus x squared. So 5 minus 5x squared over 1 plus x squared squared. So that's my derivative. Anywhere. What's the derivative? At the point 2, 2, plug in x is 2. Put a 2 there, put a 2 there. 5 minus 5 times 2 squared is 4 over 1 plus 2 squared squared. So that's going to be 5 minus 20, negative 15 over 5 squared, negative 15 over 25, negative 3/5. So y minus y1 equals m times x minus x squared. Stop, you can leave it like that. Okay, 2.8, number 23. .823. 2.5 t squared plus 6t. Again, those of you who know the shortcut, you may not use it, although I guess you could use it as a double check your answer. Okay, so f prime, limit h approaches 0, 2.5 times t plus h squared minus 6, plus 6 parentheses t plus h minus the original function. So this is f of t plus h minus f of t all over h. This is t squared plus 2th plus h squared plus 6t plus 6h. Distribute the minus, distribute the minus, distribute to 2.5. 2.5 t squared plus 5th plus 2.5 h squared, copy, 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 copy. Okay, these two cancel out, these two cancel out, that one, and that one are left, and they all have an h, common theme. So h paren 5t plus 2.5h plus 6, cancel out the h's, limit h approaches 0. 5t plus 2.5h plus 6. Now I plug in, that goes to 0. So 5t plus 6. Okay, the last one I want to show you was 2.8, number 9. Draw the derivative of that one. 2.8, number 9. Okay, the derivative does not exist here, or here, or here, or here. Slope here looks like about -1/2. 1, -1, +1/2. Okay. So there we go. -1/2, 1, -1, and 1/2. So that's supposed to be the derivative function. Oh, I have it right over here. I drew the funny looking W. So -1/2, +1, -1, +1/2. All right. Finally, 41 to 44 talks about where is the function not differentiable. How do we not have a derivative if I cannot draw a tangent line? Okay, so there is no tangent here. That's called a corner point. Okay, there's an abrupt change. So no derivative there. If the function is not continuous, then I don't have a differentiable point. And also at a vertical tangent, the slope is undefined. Okay, it basically means I don't have the slope of a tangent line. Okay, so 41, where's the graph not differentiable? It looks like at -4 and 0. -4 and 0. 42, function's not continuous here, and there's a corner point here. So -1 and 2, function is not differentiable. Okay, but I can draw a slope here and here and here and here and here. Okay, here not continuous, and let's assume here they mean a vertical tangent, straight up and down. So not differentiable at 1 and 5. And here corner point, not continuous, corner point. So for 44, -2, 1, and 4 are the points where the function is not differentiable. All right, so that was a combination of section 7 and 8.